Hi everyone, and welcome to 90 Days of DevOps, the 2024 Community Edition. We'll discuss Kubernetes RBAC as well as showcase how to achieve it using Ansible and HashiCorp Vault. In order to effectively secure your Kubernetes cluster, it is essential to carefully select the appropriate authentication mechanism. As a powerful and widely used container orchestration tool, Kubernetes offers a range of built-in mechanisms for authentication. Each of these mechanisms has its own unique sets of strengths and weaknesses that must be thoroughly evaluated in order to determine the best fit for your cluster. This includes considering factors such as level of security offered, the ease of implementation, and compatibility with your specific cluster setup. Ultimately, the process of selecting an authentication mechanism for your cluster is a critical step in ensuring the overall security and stability of your system. The general consensus tends to lean towards keeping authentication mechanism options to a minimum. This approach serves to streamline the process and reduce complexities that may arise from having multiple authentication methods in place. That's the subject of our discussions today. Managing users in Kubernetes. As most of us know, Kubernetes is a powerful and flexible orchestration tool that allows us to deploy and manage our application with ease. But what about the people who interact with these applications? How to ensure that the right users have the right access level to perform their specific tasks? That's where user management comes in. In this talk, we'll focus on how to manage users in Kubernetes in the usual way.
Let's now take a moment to introduce ourselves, shall we? Andrei here with me is a senior solutions architect with a focus on designing and implementing complex systems at scale. As a highly experienced DevOps consultant, Andrei brings over 20 years of valuable knowledge and expertise to the table. His skill set includes a wide range of experience in system and network administration, automation, and nonetheless security.
Elif is a senior DevOps engineer having considerable experience in implementing, administrating, and optimizing everything related to infrastructure. She constantly and consistently contributed to IT communities, either by delivering talks or by writing about various topics. We are also both HashiCorp ambassadors and co-organizers for local meetups. We represent Netfinity Group, an IT services company offering managed services, application management, support, and IT strategy consulting solutions from the main office in Bucharest, Romania.
Thank you for the introduction, Andrei. Quite nice.
Thank you as well.
The concept of role-based access control is quite old. It originates in the 1970s and 1980s as part of efforts to improve computer security. However, it was formally defined in 1992 at the National Institute of Standards and Technology. Role-based access control roots in government and security standards underscores its importance in secure system. RBAC is a security approach that manages access to computer or network resources based on user roles within an organization. It enhances security by ensuring only authorized users access specific data. It simplifies the management of permissions by assigning them to roles rather than individuals and adheres to the least privileged principle, granting users only the access necessary for their roles. Role-based access control is crucial for compliance with regulatory standards. It reduces operational costs by streamlining permission management and ensures consistent application of access control policies across the organization. This approach is particularly valuable in large or dynamic environments where user role and access needs frequent change. Major companies such as Target and Equifax have experienced data breaches where unauthorized parties did gain access to sensitive data. These breaches often involved human error, such as stolen credentials, phishing, and employee misuse. According to the data from Verizon's 2022 Data Breach Incident Report, 82% of data breaches involved the human element, and proper access management could have prevented many of these incidents. Additionally, the report highlighted issues such as privilege creep, where employees end up with more privilege than actually it is necessary. This significantly increases the risk of internal and external breaches. In the context of cloud networks, a report from Palo Alto Networks indicated that nearly 99% of cloud users, roles, services, and resources had access privileges, which drastically increases the chances of data breaches. These insights point to the importance of RBAC in preventing unauthorized access and data breaches.
So we talked about RBAC in general. How about in relation to Kubernetes? Kubernetes introduced RBAC in version 1.6 around March 2017, making a significant shift in how access could be controlled in Kubernetes environments. Prior to RBAC, Kubernetes relied on less flexible access control systems like ABAC, attribute-based access control. Kubernetes implements role-based access control as a means to manage authorization decisions, allowing administrators to regulate access to Kubernetes API resources based on the roles of individual users or groups within their Kubernetes cluster. So we have roles and clusters. Roles, which define a set of permissions within a specific namespace. These permissions are limited to namespace where the role is created. Cluster roles, which are similar to previous discussed roles, but these are not limited to a single namespace. They apply across the entire cluster. We have role bindings and cluster role bindings. Role bindings grant the permission defined in a role to a user, group, or service account within a specific namespace. Cluster role bindings ground those permissions defined in a cluster role across the entire cluster. So permissions are defined by verbs like get, list, create, delete, for example, on Kubernetes resources like pod services nodes. We employ the principle of least privilege using specific resources and verbs to ensure only the permissions required for the workload to function correctly are applied. Elif, how about RBAC in Kubernetes?
Well, Andre, I think you are most surely know that RBAC is actually an optional feature. However, most major distributions ship with it turned on by default, including those from managed cloud providers such as EKS or EKS and so on. We are able to check whether this feature is available in our clusters by running the command available on the screen. So it is the kubectl API versions grep rbac.authorization.k8s. This command should emit some output if RBAC is enabled. Otherwise, in case this is turned off, the command doesn't produce any output. We are able to activate it in the Kubernetes API server by issuing the flag -- authorization mode equal RBAC flag as displayed in the PowerPoint presentation, being the first command. The role-based access control API declares actually 4 kinds of Kubernetes objects, as you have stated already, Andre. These are roles, cluster roles, role bindings, and cluster role bindings. We are able to describe or amend these objects using tools such as kubectl, just like any other Kubernetes objects. What about users or subjects in Kubernetes? There are 2 types: service accounts, which are managed by Kubernetes, and normal users. In this regard, it is important to note that Kubernetes does not have objects which represent normal user accounts. Even though a normal user cannot be added via an API call, Any user that presents a valid certificate signed by the cluster's certificate authority is considered authenticated. In this configuration, Kubernetes determines the username from the common name field in the subject of the certificate. From there, the role-based access control subsystem determines whether the user is allowed to perform a specific operation on a resource.
Let's talk about what happens when we issue kubectl apply. Look at this oversimplified diagram, please. When one executes the kubectl apply command, the request is then submitted to the cluster. These actions initiates an important chain of events within the control plane of the Kubernetes system. The initial recipient of the request is the API server, which holds a pivotal role in managing the cluster. Upon receiving the request, the API server undertakes the task of parsing it, ensuring proper formatting and syntax. It will eventually store the object in etcd, the primary database of the cluster. This process is crucial in maintaining the integrity of the cluster and ensuring proper functioning of all its components. The first component is in charge of authenticating requests. Kubernetes uses client certificates, bearer tokens, or a proxy to authenticate API requests through the dedicated plugins. You can enable multiple authentication methods at once. You should usually use at least 2 methods. So we have service accounts tokens for service accounts and at least one other method for user authentication. When multiple authenticator modules are enabled, the first module to successfully authenticate the request short-circuits the evaluation. The API server does not guarantee the order the authenticator runs in. So how about TLS client certificates? Because we talked about client certificates. The Kubernetes Certificate and Trust Bundle API facilitates automated provisioning of credentials by offering a programmable interface. This allows Kubernetes API clients to request and receive X509 certificates from a certificate authority. What's the process of certificates and certificate signing requests? Well, a user or service creates a private key and a CSR, which contains the public key and the identity information. The CSR is submitted then to the Kubernetes API. An administrator on an automated system reviews and approves that CSR. Once approved, the Kubernetes CA signs the certificate. The user or service then receives the signed certificate from the Kubernetes API. How about components, Elif?
Well, very nice pointed out, Andrei. We are almost to the point when we reach the hands-on time. However, before deep diving into how to glue everything together, let's take a closer look at the components of our demonstration. There are 3 major elements. Kubernetes, of course, which is the star of our presentation. We have also Ansible and HashiCorp Vault, and let's take them one by one. I'll start with a, let's say, quick wrap-up or quick overview upon Kubernetes. This is a game-changing platform for container management. As technology continues to evolve, so do the complexities of building and deploying real-world applications and services. With Kubernetes, these complexities are alleviated by treating servers as resource pool and monitoring usage to determine the most efficient placement and scaling of containers. This not only streamlines the process, but also maximizes resource utilization and minimizes costs. However, Kubernetes is not just about resource management. It comes equipped with a plethora of features that make building systems consisting of multiple containers from easy application deployment and scalability to robust monitoring and self-healing capabilities. It is important to remember that Kubernetes simplifies the way we manage and maintain complex systems. With its ability to seamlessly orchestrate and manage containers, Kubernetes has become an indispensable tool both for business and developers. Ansible, it was the second component of our demonstration. It is an open source platform or automation tool used for IT tasks such as configuration management, application deployment, intra-service orchestration, and provisioning. Ansible aims to provide a simple yet powerful way to automate multi-tier IT application environments. It uses a no agent, no custom security infrastructure design, relying instead on existing SSH and WinRM protocols to connect to remote machines and execute tasks. This design choice reduces the overhead of managing additional software and security protocols on client systems. The primary feature of Ansible is use of playbooks. These are written in YML. Playbooks allow users to define the desired state of their IT environments in a clear and declarative approach, making it easy to deploy and manage systems and applications across a wide variety of environments. Ansible's simple architecture and powerful capabilities make it a popular choice for automating a wide variety of tasks. Last but not least, we have HashiCorp Vault. This is a security tool that specializes in secrets management, data encryption, and identity-based access. It provides a centralized platform to securely store, access, and manage sensitive data such as tokens, passwords, certificates, or API keys. Vault is designed to tightly control access to secrets and protect them through strong encryption, ensuring that sensitive data is only accessible by authorized entities. It supports a variety of backends for storage, it offers detailed audit logs, and integrates seamlessly with various clouds and on-premises environment. Its dynamic secret generation feature minimizes the risks of secret exposure by generating temporary credentials on demand. Vault is robust and flexible. This is why it's a preferred choice for organizations aiming to enhance their security posture in complex IT environments. I think you've used Vault for quite some time, isn't it, Andrei?
Yes, I did. So I think it's enough content and data about our environment and our components. Let's switch to a live demo. When it comes to user authentication to the Kubernetes API, we understand the importance of security and confidentiality. That's why we've selected Ansible as our preferred tool for automating the process of creating client certificates. Instead of spending a lot of time manually creating those critical files, with Ansible we can guarantee a straight and efficient process to generate those critical files. But that's not all. In order to further safeguard those certificates, we will be adding a Vault cluster, like Alif mentioned, specifically a key value secrets engine. This will not only ensure secure storage of our certificates, but also streamline the access for authorized users. We believe that this combination of Ansible and Vault will not only be the highest level of security, but also provide a seamless and hassle-free experience when it comes to managing client certificates. So by leveraging provided variables, Ansible will assign specific actions, meaning roles and cluster roles, for users. This approach aligns with the principle of least privilege, ensuring that users have access only to the resources necessary for their roles, thereby enhancing overall security and efficiency in our systems. This method not only streamlines the process but also fortifies our security framework, making sure that each user access rights are carefully calibrated and aligned with their specific operational needs. So let's go to the terminal window. A moment, please. Within our project, there is an Ansible folder containing all the files we need. This is the structure. Our inventory is determined by the Kubernetes context we use. The target is to create users with our names using various rules and permissions. So let's run the playbook. Shouldn't take that long.
I cannot help but notice that only you have cluster role privileges for admin. I have quite restricted privileges.
Yes, by design. So these are the files we employed to generate certificates and related kubeconfig files. And we can also list the entries under the key value secret engine we used. So let's test the access using a generated kubeconfig. Both users get to list the pods, as you can see. But Elif is not able to edit the stateful set we used in Vault namespace. Again, by design, Elif.
Well, I couldn't help but notice it. Well,
See, it's forbidden. Yeah, that's it. Let's switch back.
so everything happened with just issuing a command, right?
Yes, Ansible.
That's quite awesome. Well, actually, guys, this was our demonstration. However, there are several opportunities for automation and integration. A few examples would be auto-approval and rotation. Some clusters are configured to automatically approve certain CSRs, and tools like Kubelet can automatically create and renew certificates as needed. Additionally, one could integrate a Kubernetes cluster with an external CA. So in order for signing certificates, integrating with high-level security systems. I'd say that beyond these practical benefits, RBAC has found extensive applications into different areas. For example, in everyday life. RBAC, this model isn't limited to computer systems. It mirrors also real-life scenarios. Let's take, for example, a hospital. Different staff, such as doctors, nurses, administrators, have different access rights to patient records, similar to how role-based access control works in IT systems. What example would you have in mind, Andrei?
Let's talk about RBAC and compliance. It plays a crucial role in compliance with various regulations like HIPAA, GDPR. By controlling who has access to that resource, RBAC helps organizations meet legal requirements for data access and privacy. Do you have another one?
Oh, this sounds great, but I'd like also to add that from a scalability standpoint, RBAC can be quite challenging. It is excellent for managing permissions. However, it can become complex and hard to manage at scale, and this might lead to development of more sophisticated management tools and strategies. However, I think you mentioned we did say something about least privileges principle, Andrei? Could you explore it a bit more?
Security in general. We can talk about RBAC and zero trust security, for example. It's an essential component for zero trust security. As a model which operates on the principle of never trust, always verify, RBAC basically helps enforce the principle of least privilege, a cornerstone in zero trust.
Well, last but not least, RBAC does influence also business processes because it often requires organizations to rethink their business processes and how to map to access control. This can lead of course, to a more streamlined and secure operations approach.
Thank you, Elif. I think that's all from us. Thank you for listening, and I think we enjoyed it. Hope you enjoyed it as much as we did. Bye.
Thank you.